This is Jonathan Park's submission for ECE 4150 Lab 3, the air quality data. So first we'll take a look at our Django app. So in views.py I've added a new function that will allow the user to download the raw data as a CSV file. You can see I'm scanning through the table and pulling the values and then writing them to a CSV file. I've also added a link in the template and a new URL that will allow this function to be called. So now let's start our server to start our app and then go back to our web browser. You can see that the AQI data output is showing up on this main page, and then under the raw data tab we have our raw data and also now a link to download this data as a CSV file. So I click this button that will allow me to download this is AQI-raw-data.csv. So now I'm going to move that to my folder that has my script so I can analyze it and plot it. So now let's go into our Python script. So I've named this AQI plotter. You can see here I have a function that says plot from CSV that will read in this file and then split it based on station number and then develop two subplots for that data. So in order to run that, I'm going to run this function with the AQI raw data.csv as the input, and then let's run our plotter. You can see that we've read through our CSV and then we've plotted our data here. So we have data for ST102 and data for ST105. For the next exercise, I need to plot the data in real time, updating from the DynamoDB. So if we take a look at our plotter again, not only do I have functionality to plot from a CSV, but I have functionality to plot from a DynamoDB. So I have a helper function that will allow me to scan the tables and get the relevant data. And then inside this loop, I'm constantly pulling data from the database, updating my plot, and then pausing the plot and updating it. So the way I have this set up right now, I'm displaying the 20 most recent values for the plot so that it doesn't get too cramped when you have data with different timestamps. So let's run the plotter. Oh, actually, I need to, in order to get this to work, I need to comment out this portion. And I also need to start my pub that will be pulling in data in real time. So if I just start this plotter first, the data will just be stagnant because no new data is streaming in. So you can see that data here. And then if I start my pub, this plot should start updating with the new data as it's being published. So you can see that it kind of gets jumpy here because of the jump in the timestamps between when I started the data collection before and when now. But you can definitely see that the new data is being added, and eventually this large gap will go away after more than 20 samples have been collected. So I'll let this run for a few seconds, and while that's happening, I guess I can double check with the air quality table data and see we're at 87 items, refresh 91, 92, and you can see that that's being updated as this mypub is running, and we can see that jump has been removed, and now we're just streaming in data in real time. So now we can close this, and the last thing and stop the app. So the last thing we wanted to see is the email notifications for high AQI. So if we look at our data output table, we can see that our AQI level for station 102 is 307, and for ST105 this is 318. Those are both above the safe threshold, so we should be receiving emails now. So I have made a Lambda function that should send these emails. You can see it's triggered by a CloudWatch event. And so this function will parse our tables, check the AQI values against the acceptable regions, and then send an email to the user. So in my email, I should have been getting emails right here that will say the air quality rating for ST102 is hazardous and ST105 is also hazardous based on the values that we're seeing in the lab report. So that should be all the requirements for Lab 3.